Okay, all right. So as I said, I would send an electronic textbook to the class rep, and then he's supposed to share the textbook with you. So these slides are prepared from Business Information Management by Benson and Tribe, 2008. And as I said, my name is Eli Fianu, Dr. Fianu. You can call me Dr. Fianu. All right. All right, so would talk a little bit about information management. Today, business organizations create and use vast quantities of information as never before. Information has become a valuable asset to businesses. Information supports day-to-day business operations, decision-making, and almost any business function in any business firm. Enterprises invest in information technology as they have proven to deliver an economic value to the business. This economic value can be expressed through an increase in competitiveness, high productivity, and increased revenue. So you would all bear with me that I always like to look at what I call the digital firm. So the digital firm is a firm or an enterprise in which almost all the relevant business processes are automated. So you cannot actually automate have 100% automation, but a typical digital firm would want to automate almost all the relevant business processes. So in an attempt to do that, it would require some investment in information systems. I hope you know the difference between information technology and then information systems. Along the line, I'm sure you have been exposed to some of these concepts. So if I throw the question to you, who can tell me just one difference between information technology or IT and IS, what we call information technology and information systems? Who can try and give me one difference? Try to probably compare and contrast so that we can just get one unique distinction. And remember, as I said, I will award people who participate in class. So take note of that. Anybody?
Yeah, please.
Yeah, I'm listening. I thought someone was speaking. Okay, all right. So nobody wants to talk. I'll continue. So we would have to look at what benefits that an organization will derive. If it's a digital firm, if it invests in information systems, what are the benefits? Because you could have two different enterprises, one that tries to invest in information systems, the other would want to keep to some manual systems to get the business running. But there's also the issue of scalability, or when we start moving, when we look at size of the enterprise, you would look at it from this point of view. You can have what we call the micro business. Then we can look at the SME. Then we can look at the typical corporate. If you look at a micro business, investing in information systems might not, at the micro level, might not make sense to a lot of people. When we move to the SME, then we are looking at, okay, can a business decide to invest in information systems or not? But as the enterprise becomes bigger, it gets to a point where you cannot do without information systems. And I'm sure you can attest to the fact that every serious corporate entity or corporate venture would want to invest in information systems. And as it is said here, you are working in a very competitive environment. If you take any industry, for instance, the banking industry, even insurance, healthcare, etc., you would realize that you cannot take decisions in isolation. You want to remain competitive. So you would have to make sure that you are abreast with technology so that you can come out with innovative products and services, etc. Keep your market share and even grow your market share. So when we look at competitiveness, we look at high productivity and increased revenue, etc., you would realize that it is critical that as a business venture, you invest in information systems or information technology. So we'll look at data and information. Okay, we need to look at the difference between data and information. We are saying raw, unprocessed streams of facts are usually referred to as data. Entries of numbers, text, images, or other forms of computerized output are considered data. So the key thing, I've tried to highlight the keywords. So raw, unprocessed streams of facts. Now we call these facts because, for instance, if you are taking data, let's say you are collecting data that or business data, you are not going to collect stories. You are not going to take stories from people. You are taking facts. If you want to, let's say, create a new customer. If I say create a new customer, I don't mean that you are going to create a human being. But for instance, if you want to open a bank account for a customer, we can say you are creating a new customer. Whatever information you are taking from that person, we'll call it facts, because we believe that these are correct things we are taking, and there is an element of truth. So there are very divergent views about what people call truths, facts, etc. But from the data point of view, we believe that when we collect information that we want to use, we collect data that we want to use for business processes, we call them facts. So you will have to look at these keywords: raw, unprocessed streams of facts, and we call them data. Okay. Entries of numbers, text, images, or other forms of computerized output are considered data. Raw data, however, is a relative term, as data processing may have a number of stages. So the output from one processing stage can be considered to be the raw data for the next processing stage. So processing can be in stages. So we can have input, output, input, output. So output from one stage can be an input or raw data for another stage. After data is processed and shaped in a meaningful form, useful to a person or computer, it turns into information. So remember processing, and then into a meaningful form. Then we would call it information. Okay, so let's try to make it a little bit more practical. So you can see this, this diagram or schema where to this side we are saying is data, to this side is information. So let's say you have sales receipts. I mean, the sales receipts has certain information and certain data. Okay, let's not mix the data and then the information. So let's say if you go to Accra Mall, right? If you go to Accra Mall and go and buy stuff, can someone tell me the kinds of things you find on the receipt? Can someone help us out?
Say tax.
Pardon me?
VAT.
You see what? VAT. Please, I didn't hear you well. Can you repeat what you said? Anybody else? If we don't talk, I'll not move on.
Sir, please, can you repeat the question again?
What I'm saying is that I'm trying to explain this this picture or diagram or whatever you are saying. So I want to make it as practical as possible. So I'm asking you, for instance, if you go to the Accra Mall, you go and do your shopping and they give you a receipt. What are the things? What things will you find on the receipt? What kind of data will you have on the receipt?
Sir, the items you bought.
Okay, so please be specific. In this class, I want us to be very, because we are looking at data, we are looking at information, and then we are looking at how we can build accurate databases, and then how we can manage them. So please I want you to be specific. Let's say from the top of the receipt to the bottom of the receipt, what are the things, what will you see?
I see various titles on the receipt. So there's the item, the quantity, but then the unit price of the you see total of all the items that you purchased.
Okay, all right. So each individual would have a list of items that he or she would purchase. So it means that if you have about 1,000 people visiting the mall, let's take one particular shop, let's say ShopRite or whatever. You would have, if you have about 1,000 people or customers going to that ShopRite, and assuming everybody buys something, pays for it, the person walk away with the receipt. A receipt would have information of, or you have the date, you would have, it will show receipts, maybe ShopRite receipt. It will show you the one who is manning the point of sale. Okay, I wouldn't call the person teller, but the staff manning the point of sale or the POS. Then you would have the item. So you have an item, what we call an item ID. Yeah, maybe it will have an ID. You have the description of the item. It will have the unit price, it will have the quantity and a total or whatever it is. If it's one item, you have several items on the receipt. Now, that's just for one person. So at that point, it's just data. So I'm just trying to explain this to you. At that point, it's just data on a receipt. Okay. Now, this data is held in, for instance, what we call tables. You understand? So you would have a series of purchases held in tables, etc. That would give you an idea of, for instance, today, the whole of the day, how many items, how many customers came to buy, let's say, Coke, right? How many customers came to buy digestive biscuits? How many came to buy, let's say, some toiletries, soap, maybe lax or whatever, specific information. And all this information goes into some kind of database. Okay. Now, we would have several transactions showing within that database. These are all transactions, and you see transaction ID, etc., etc. So at the end of the day, the manager can quickly, at the close of the day, the manager can actually tell the total sales for the whole day, and then a breakdown of total sales for each items that have been bought and all that. Okay, this will be done on a daily basis. So assuming we are looking at the quarterly sales, you can sum up all these daily sales into quarterly sales. Now, the interesting thing is that right now, from this stage to this stage, you are getting more information. From the sales receipt stage to the quarterly sales stage, you are getting some information. The data is being, at least the processing, we can have simple processing, we can have complex processing. So at this stage, you can have some simple processing or certain things done on the data, summation, etc. Summation, finding averages, etc. Now, where we want to use that same information, but we are trying to get far more information from this data that we've collected, is when we want to look at the forecast. So looking at the trends for the past 3 months, which maybe is a quarterly sales, you can try and then forecast sales for the next 3 months again. Now, it would inform you about so many things. Although we cannot rely on just that, when we look at data analytics, etc., you get into trying to look at so many factors that you want to use for prediction, or what we call predictive analytics. We are not just looking at probably the raw quarterly sales, but where you are doing some more complex processing, you can then go into forecasting, where you want to be able to forecast the sales. You can do it in so many ways. You can do it for probably one particular shop, if there are so many shops across for one particular shop. For the whole shop, you can do it per item, etc., etc. And then you can even do it for an aggregation of all the shops. So that is what this tries to explain, from the raw data stage, where processing goes on, up to where we are getting a lot of information that we can use to take critical decisions. The key thing is that we are doing all these things so that we can take accurate decisions, because of we have collected facts. Remember the previous slide, they said that we are taking facts. We are not taking any stories or any fiction, but we are taking facts, and we want to use it to make solid decisions. The difference between data and information is determined mainly by how they are used in a business context. An individual entry on a sales receipt, which has a product name, quantity, and price, does not become informative to the business unless it has a purpose or a meaning. When individual data entries are processed, some utility value or meaning is added to raw data to transform it into business information. Organizing data. In order to be useful to business and effectively support business processes, data used throughout a business is organized using a data model. Let me find out from you. Have you taken any course on databases before?
No, sir. We just started one.
You have not taken any course like that before?
Yes, sir.
Sir, MIS.
You did MIS?
Yes, sir.
Yes, when you did MIS, did you come across?
We didn't do database, sir.
Pardon me?
So we didn't do any database in MIS.
But at least you were introduced to some concepts in like data, etc. Those concepts, information.
Yes, sir.
So this data model, is it new to you?
A little bit, sir.
A little
to me, sir.
Okay. So we can look at this thing from a pure database management perspective, where when we look at data models, but I don't want to, since you are management students, I don't want to take it from that angle, but we have data models depending on the type of data that we actually, or the way we want to keep data. And we can look at what we call the file system, and then we can look at several models, okay? But the most popular is what we call the relational model. We have the network model, the hierarchical model, etc. But the most popular model that we look at is what we call a relational model. So in most cases, we want to compare the typical file system with the relational model. So we'll look at the file system and then try to move slowly into the relational model. So let me go back again. In order to be useful to business and effectively support business processes, data used throughout a business is organized using a data model. A data model provides a set of principles for organizing data. Generally, data items are arranged into a hierarchy comprising of data elements and data structures. A data item is considered to be atomic or the simplest element of data organization that cannot be divided any further. For instance, in a data model for organizing customer records, it is not recommended to keep names of individuals as a single data item. It is typical to have separate data items for first and last names of an individual. That is to keep each element as simple as possible. So, depending on the way we want to organize data, and as per the guidelines that normally is set by the information systems policies and philosophies, you would want to probably adopt a particular way of organizing data. So some things cannot be accepted, or some things will not be allowed. So for instance, somebody, you have a customer, and the customer's name is John Kweku Abaka C. Okay. The person has about 4 names. Now, we don't want to capture that customer's name as 4 separate names. We would want to probably look at first name, middle name, last name. And with the concept of atomicity means that we do not want to have more than one data item within a particular data field. So as an example, we want to say, okay, in our data model, data items, when we look at data items, we want to enforce atomicity, where any data held in any field within the data structure should be atomic. So I'll give an example. Let's say we have two types of data structures, where we have a non-atomic data item. With a non-atomic data item, we have, let's say these are 2 separate, when you see these 2 separate rows, or in another sense, somebody will say field or something, but let's take it like this. Let's say we have 2 separate rows. Now, each row represents a unique customer. When it's a non-atomic data item, we have Jackson Taylor, and the 2 names are held in one field. You can call it a cell if you wish to. So this is one field. So far as we have 2 separate names held in one field, then we will say it's non-atomic. Then we say 2 atomic data items in a data model. So in this case, you see that in this field or cell, there is only one name. And then we have split the name into last name and first name. So you can see that the last name for this particular customer is Jackson, and for this is Taylor. And first name for this is Taylor and Jackson. So because of atomicity, we can clearly see that these are 2 distinct customers. But in this case, it can be misleading, because someone would assume first name is Jackson, and then last name is Taylor. Likewise, this. So depending on who is looking at this particular field, we can have some amount of confusion. Okay. So it states that here that Jackson Taylor and Taylor Jackson are not the same. The hierarchical nature of a data model is based on the fact that data elements is a group of data items, and consequently, a data structure is a logical collection of data elements. So in that hierarchy, we are looking at data item, data element, and then a data structure. So the way we organize the data items will form the data elements. And then the way we organize the data elements will form the data structure. So you can see constructs of a data model. For decades, the most popular data model used for data storage within organizations has been file-based. In this data model, logically organized constructs of fields, that is data items, records, that is data elements, and files or data structures are used to organize data. So let's try to do something. Hold on. Let's try to do something. Can you see my screen?
Yes, sir.
Okay.
Yes, sir.
So let's try to use the file system, or as the slide indicates, that the file-based structure, a file-based data structure to try and get a file. So assuming we want to keep data on this class, right? So we can decide to say this is the kind of data we want to keep. Student ID, first name, last name, so gender, and then what else?
Session.
Pardon me. I didn't hear you.
Session, evening session.
Okay, session. Okay, all right. Okay, so we start with, we can have students ID 00001. Okay, now let me use 1000. So the first name is, let me try and get some names. So is it Anima or Anima? How do you
Anima.
Anima?
Yes.
So it's female, right?
Yes, please.
So this is evening. Asante Ameyao. Which is male, and then evening. Then we can have 1002. We say Felix Donko. Who is a male. So is it regular? Do you call it day or regular?
Morning.
Morning.
Please.
Okay. So in this case, we want to keep data on all students, right? We can decide to say that, okay, we are going to use a file-based data model to keep data of all students at, let's say, GCTU. So then we can decide to have level, or let's say year of entry. Like the year of entry is better. Year of entry. So maybe this person is 2019. Let's say this is 2018. Then this is 2019. This is 2020. Okay. So if we decide to use a file-based data model, then we are now deciding that, okay, how do we decide on a data item, and then the data element, and then a data structure. So we will then say that, okay, we are, and this whole thing, assuming we are keeping data on all students probably in one file, then we can say, and assuming these are all the students, we can say this is one file that consists of students at GCTU, or this one file that consists of all first year students, or this is one file that consists of all second year students, and so on and so forth. But with a file-based approach, we are dealing with data items that are arranged in rows, and then we are keeping each data item atomic in one field, and the data structure is that we compile the list of all of the students together in one file, which will form the data structure. So for decades, the most popular data model used for data storage within organization has been file-based. So the file-based model or structure was the most common type of structure that was used until other data models evolved. And as I said, until we decided to use the relational model. But even after the relational model, the other type of models have evolved, right? For instance, we have what we call the non-relational model, or what we call the NoSQL. I mean, that just by the way, okay. In this data model, logically organized constructs of fields, that is data items, records, or data elements, and files, data structures, are used to organize data. So we can look at fields, that is the data items, records, that are data elements, and files, that are data structures. So let's go back and see. So I want to hide this thing. Hold on. So I'm going to shade. I'm going to shade specific areas, and I want you to tell me. I want to see if you understand. So in the file-based model, what I've shaded, for instance, yellow represents what? Who can tell me?
Please, data item.
Data item. Or
for animal.
Data item or
Student ID.
you said?
Student ID.
I know it's student ID, but from what let me go back again. I'll give you one more chance to see if you can. So in this data model, logically organized constructs of fields into bracket data items, records into bracket data elements, and files into bracket data structures are used to organize data. So I am going off again. I want to find out if you understand what I'm talking about. So data item or what?
Data records.
Nah, no.
Field.
Field, good.
Okay.
Data item or field. So this one I've shaded is what?
Record.
Record. Okay. Or data record or the answer is staring at you in the face. I don't know why.
Data element.
Yeah. Okay. Or the element, good. So the whole thing is what is, we'll call the whole thing what?
Files.
Cover the whole thing, what?
Files.
File or
Data structure.
okay, good. All right. In context of a file-based model, a record can be considered a data element. The structure of a typical record comprises of a set of data items that generally represent a meaningful entity. So we are looking at the file-based model. Now, we would normally look at what we call the entity relationship model or the ER model, and then we move on to the relational model. So when you see an entity here, it says that the structure of a typical record comprises of a set of data items that generally represent a meaningful entity. The entity being a student, that human being called Anima. Is it Anima, right?
Anima say.
Oh, Anima. Oh, sorry. Please pardon me. I'll not buy Schnapp. I won't buy Schnapp.
I hear you.
So Anima, that entity called Anima is represented by a set of data items called a record. So when we go back, you will see that we go back, we will see that this whole set of data items, right? This whole set is the record. But remind you, it represents a unique human being who is a student. So you can tell that this whole record that I have shaded now is Anima. And we can call Anima an entity. That is a student. It's an entity on its own. Likewise, Asante, Felix, and then Dora. A customer record may consist of data items such as customer name, address, contact telephone number, etc. A collection of customer records from a data structure stored in a file. So the file-based model comprises of several files that hold logically related data depending on how we want to organize. So we can decide that, okay, we will create a file of all female students in the school, or a file of all weekend students, etc., 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 depending on what we want to use it for. But the file-based model is not as scalable as, for instance, a relational model. The file-based model has several problems. We can look at, so when we are doing database, we can look at what we call several anomalies. There are so many anomalies that come with it because we are keeping separate files in isolation, such that when there is a change in one particular entity, there is a change in any of the data items that may change, you would have to then go and try and change the record of that entity in all the several files that are existing. So in organizing data, the file-based model is not a preferred model because of the issues that that are associated with it. Organizing records together in a specific file means that there exists some sort of a relation between data elements. For example, a particular business organization stores data about its customer orders in a file-based form. So we can have, assuming you are a student, but you are doing some business on the side. You are doing some business on the side. Let's say you decide to sell hand sanitizers on campus, right? So you want to keep some data. You want to at least, that's what every average computer literate person would do. A person is likely to probably open an Excel file and start trying to track or keep that data. So assuming you have a list of customers, you have their names, their contact numbers, probably their addresses, etc., etc. You'd want to be able to have information or data on all their orders. So you create a file where you are keeping their orders over there. And it will work for probably maybe not selling hand sanitizers, but maybe you are selling things that they order and you deliver later. Maybe some particular dresses or shoes. So you have the pictures of the shoes or the dresses, etc. And then you show it to them and then they tell you, okay, I want this color. So then you can create a file where you have their names, etc. Then you want the product is this is the name of the product, then quantity and then color and all those things. So it means that the information, I won't say information, the data that you are keeping there, all the records should be logically related. It should be, if it's on orders, it's on orders. If it's on something else, on something else. That's what it's trying to say. In a data model, an individual data item is characterized by some sort of a format, typically referred to as its what? Data type. Data type indicates not only acceptable form of a data item, but also its format and possible range. Furthermore, data type declares the appropriate operations that are possible on a data item. Over the years, a series of standard data types have emerged. Data types commonly used by business information systems include numbers, text, dates, and time, and others. Okay, so what it means is that each data item is characterized by a sort of format. So we will say it has a data type. So let me explain to you. So assuming we want to look at data types. For instance, the student ID, will you say it's number or will you say it's an integer or whatever? Can somebody answer?
So it's a number.
It's a number. So Felix, in your opinion, what is the data type? Can somebody answer? Nobody wants to talk.
Please, could it be a data element?
Oh, you are going overboard. You are going far away. Okay, let me go back to the slide that I would help you out. Over the years, a series of standard data types have emerged. Data types commonly used by data systems include numbers, text, dates, and time, and others. So, yes, madam, come back again. This time, come well. Hey, madam, you don't want to come back again? Martin, are you there? Martin.
Yes, sir, I'm here, sir.
Okay. So, what data type do you think is this? Based on the information I shared with you on the slide. Okay. All right. So what the slide said was that each data item has a format. And the format tells you that for instance, the data type. And it can be a number, it can be text or whatever. So for instance, when we look at this one and we say format, right? We can have number, we can have currency, we can have date, time, etc. We can have text. That is what I wanted to say. So, for instance, the default format for instance, for that first name column is general, right? So in Excel, Excel is not a typical database, should I say, application. So it has certain default formats, but we can decide that, okay, for student ID, that data item, we want to make it what? Number. And then we define that it's number, but what? With 0 decimal places, right? Then we can say that for data item, for first name, we are going to say it is what? Text. And so on and so forth. But you do not just get up and choose any type of data type, because I'll show you the reason why. So for instance, data type indicates not only acceptable form of a data item, but also its format and possible range. So it means that you must also, the data type must also inform us about the particular range that values there can fall within. Furthermore, data type declares the appropriate operations that are possible on a data item. So the operations means that, can we add all the values in that particular data types in that particular column? Can we add them? Can we perform mathematical operations on them or not? Because if it is, for instance, text, if the data type is text, we cannot perform mathematical operations on them. That's what it means. Standard data types, such as text, which is a series of characters composed of characters from the alphabet and other symbols. Numbers is integer, decimal, float, and other types of numbers. And then time, including dates, seconds, minutes, and hours, are amongst the most commonly used in business information systems. So the most common data types that we use in business information systems is, for instance, text, numbers, time. In recent years, it became impossible to store data only in standard data types. Modern information systems have to cope with multimedia such as graphics, audio, and video data. So what it means is that as time went on, the kinds of data that we are keeping changed from the normal types of data into, for instance, multimedia, such as graphics, audio, and video data. So for instance, we want to we have customers. We want to have pictures of all our customers. We want to store them. We will not be able to store them in the standard data types. So there was a need that we would have to look at other forms of data types. For example, data elements of a photographic image are pixels. Data in its various types are stored by hardware using what? Binary representation. Data in its various types are stored by hardware using binary representation. A unit of the quantity of data stored is typically expressed using what we call bits. We call bits. 8 bits make up a byte. 8 bits make up a byte. A byte represents, for example, a character such as 1. So if we see a character 1 as as we see it now, maybe AS in the character, this is stored in on hardware in a form of bits. So we have 8 bits making this character, but it's in a binary form. Over the years, capacities of hardware used in modern computing have grown exponentially and will continue to do so. Typically, hardware storage capabilities are expressed in kilobytes, megabytes, and gigabytes, where a kilobyte is 1,000 bytes or 10 raised to the power 3. Megabyte is 1 million bytes or 10 raised to the power 6. And then gigabytes, which is a million bytes, that is 10 raised to the power 9. And then we have a terabyte, we have so and so petabytes, and we go on and on and on. That's where we enter the realm of what we call big data, where we have a very huge amount of data. Information can be in a variety of forms and is stored in various channels. Almost any business is now operating a database that is a structured approach to information storage. The corporate database often becomes the center of business operations and decision-making. Some or all of the business areas can draw on the information stored in a central database. So if we look at a typical business venture, and I'll call, let's say, if I go back to the concept of the digital firm, we would look at not file-based systems, but databases, where we have moved from the file-based kind of model. And when it comes to what we call business intelligence or BI, databases form one of the core components of business decision making, because a lot of data is held in there that can be processed into meaningful information. So we will look at business intelligence. We have to look at business intelligence as against transaction processing and all that. So let's assume we have a centralized sort of database, right? We will typically have different business functions. So in let's say in our organization, we have sales and marketing function, we have the finance and accounting function, human resource function, production. Okay, so what kind of data will support sales and marketing? What kind of data will support finance and accounting, HR, etc.? So we must have, if it's a centralized database, then we must have data on customer orders that can serve sales and marketing. We can have data on general ledger that will support finance and accounting. Data on employee records that will support HR. And then data on inventory and stock control that will support production. So you can see database at the center of business functions. The sales department stores data about customer orders. Finance and accounting use sales data to generate invoices and process payments. The marketing department draws on the customer data and sales information for effective marketing campaigns. HR store information about company employees, their skills, and professional development needs. A central database facilitates keeping track of stock and production levels for manufacturing and production areas of the business. Centralized information helps even a small business run effectively and rely on real-time information. Although most think of a database as the main source of information in a business, a significant amount of information is actually unstructured and decentralized. So if there is a centralized database, it does not mean that every single data in the organization will be found there. It means that there could be pockets of data that are sitting outside it, but because they do not form part of the data capturing processes or the lay down processes on what data must be captured or must be, that is policy states that this must be captured and must sit in this database. So you could have other pockets of data that could be sitting elsewhere. And then we have to also look at what we call structured and unstructured data. Because, for instance, if you are looking at a relational model, if you are looking at a typical relational model, you are dealing with structured data. But there could be other types of data that are sitting outside this framework that is actually unstructured. Unstructured data sources include documents, spreadsheets, emails, presentations, intranet, and web pages. Information is sometimes said to be distributed across different sources and areas of the business. Decentralized information is located on employees, laptops, mobiles, desktops, personal devices, spread across departments, local and regional offices. So I'll give you a typical scenario. So you could have a company where you have several branches. Now, the branches can have what we call a CRM, or customer relationship management system, that tries to manage customers and help, let's say, customer service people to serve customers. That CRM might not be configured to take every customer information, but probably there's a branch somewhere that feels like they need to keep some customer data that is not captured in a CRM. So they also might have a spreadsheet where they are keeping this information. Now, mind you, that spreadsheet might be unstructured because the one who is capturing it is not skilled enough to ensure that the data is structured. So it means that there could be some data items that have different data types. Some could be integer, some could be number, and so many things. But it is also data that they are keeping, which they use for operational purposes. So that's an example of the kind of unstructured or decentralized data that we can think of. Any questions so far? Anybody with any question? Information is sometimes said to be distributed across different sources and areas of the business. Decentralized information is located on employees' laptops, mobiles, desktop, personal device, spread across the as I've said. Okay, so that's why I say information everywhere. Okay, so we can talk of static data and moving data and endpoint. So if we aggregate all this, it will form the entire data that the organization can have. So with the static data, we can talk of database servers, data held in database servers, in file systems, as we said, storage area networks, directly attached storage, file servers. Okay. And in moving data, we can have email, we can have voice over IP, we can have blogs, we can have wikis, HTTP, FTP, and IM. Okay. Then endpoints. We can have desktop, laptops, smartphones, USB flash drives, zip drives, floppy disks, optical media, CDs, DVD, memory cards, iPods, mobile phones, etc. So it means that you could have several channels of business information, and these are the realities of issues of data within the organization. In many organizations, data sources have a tendency to exist separately. Employees of different departments may have developed their own ways of keeping track of data, but as this process continues for a significant time, the centralized data may impose some problems. Right? Without an organization-wide plan and data administration procedures in place, business may encounter such problems as one. So as I mentioned, these are some of the issues when you have decentralized data, especially pockets of data like file-based systems, etc. So we can have what we call data redundancy. Whereas data becomes duplicated and stored at several locations in more than one file. So as I said, you can have a file that has all female students in level 100. Then you could have another file that has all female students in the school, another file that has all female students on a weekend, and so you could have the particular records of one person scattered all over the place. And that's what we call data redundancy. Poor data availability. Data becomes isolated and available only to the owner of a particular file in a file system. Sharing of data and its visibility to employees becomes reduced. Poor data security. Data spread across business in various forms and locations reduce the ability of a business to set proper security controls and ensure authorized access to information. So it means that, for instance, if somebody is keeping some data on customer, let's say at the branch manager has said that, okay, you know what, we are not getting this data from the CRM, so I want you to open a spreadsheet and keep this data there. Lo and behold, that person might be keeping that data on a pen drive, and then he goes home, he or she goes home, and then this brother or sister says, oh, I want to use your pen drive for something. Then forgetting that is having that information, a parent gives the pen drive away to the brother or sister. Let's assume maybe that the data has names of customers who probably are owing, or they might have deposited some money somewhere. Then you can tell that you have given this confidential information out without realizing it. So these are the issues that come with isolated file-based data held at different locations, etc. Error-prone data. When the same data exists at multiple locations, it becomes more vulnerable to human errors introduced by different employees and mistakes tend to go unnoticed for longer. So as I said, this is what you see. You can have data on this. Maybe one. Let me try and get some of the. Maybe you could have Felix Donko, right, in this file here as because we are keeping all this file consists of students that have something in common. Let's see, we are keeping them here. Then you could have Felix Donko in another file somewhere, and then probably the student ID might be wrong because it's a human being that created that file and can make mistakes, right, etc., etc. Okay, so I wanted to have a quick recap of what we've done so far. Then I'll give the chance for questions, and then we can close. Okay, so we started by introducing having an introduction to information management, and I give the reason why it is important for businesses to have information systems, the benefits, etc. Then we looked at data and information, looked at what data is and what happens before data becomes information. Then we looked at a scenario here. Where we use the Accra Mall scenario to try and explain the migration from data to information. Then we look at organizing data. We looked at a data model, look at data items, data elements, and data structure. We looked at atomicity. And then that hierarchy of the data model. We looked at a file-based model. We looked at data types, the common data types, and looked at the binary representation and the bits, what's the bits and the bytes. We look at information everywhere. The centralized data access for organizations. And we looked at how each business function. When I say business function, I mean a department within the organization. How each of them requires specific data to be able to operate. Then we looked at unstructured data and decentralized data. And various channels of business information. Then we looked at problems that can result out of, because there is no organization-wide plan and data administration procedures. Okay. And problems of data redundancy, etc., that may result because of isolated file-based data sitting different locations in the organization, etc. So the next session will continue, and then we'll look at strategy and information systems, and then another topic as well. Okay. Okay, so I want some feedback from you. If you have some questions you want to ask, etc.
Hello, sir.
Yes.
Please, I want to know if the record will be given to us.
The recording.
Yes, please.
Do you want me to give you the recording?
Yes, please.
I would normally see when you do a recording like this, it's almost 2 hours or so. The file becomes huge. Do you want the audio or you want the video?
Sir, we want the video, but I think most of the time the recording they put it on Telegram, as in group.
Put it on
We have a
Telegram.
Telegram. Yes, we have a group on Telegram. So I think the class rep, if the class rep can take the recording and then put it on Telegram file.
What is the average file size that you normally have?
So please, with that one, the class rep will determine.
The class?
The class rep would
Martin, are you there?
average.
Martin?